Good morning and welcome to Triasta's webinar on the process improvement capabilities of the Triasta solution. We're going to begin this morning with a look at the various tools and capabilities we can offer you if you're a business analyst working in the domain of trying to understand how to convert an as-is to a to-be and make improvements on the way. So we're going to start by coming into the Triasta website, triasta.co.uk, and example process libraries. Please feel free to click along in your own environment. We use online tools here as much as possible so that you can refer to them during the webinar or immediately after. And I've clicked down into the second library here, the AlphaChoco library, excuse me, which is here in celebration of World Quality Day, where the CQI went out to the industry and said, we're looking at this chocolate supply chain as a way of understanding process improvement opportunities. So we put together a set of processes here that relate to, a mythical but typical situation in most industries of the supply chain, with a view to helping our customers understand how we can help them improve their processes. So with every process in a Triasta process library, there's always a trigger point, some start point, and we then move left to right through the process. When we get to the end of a page, which is typically sized to fit your printer, we then step over the process from beginning to end. Each of the white boxes is an activity. It represents work being performed. And as such, the data associated with that activity is typically to do with cost, resources, effort, that type of thing. These data palettes will obviously be focusing quite a bit on this morning. You can have as many or as few as you like. You can customize the out-of-the-box data, and you can add and remove data as you wish. And the data is also object dependent. So when we're looking at deliverable objects, typically there's very little of interest in those in terms of understanding cost, time and effort and so on. But anything that is work being performed from a business analyst's perspective, there's typically quite a lot of data underpinning it. And eventually we reach a point where the process stops. So in this library we have an end-to-end process made up of 4 steps. And you can, like I say, drill through those as you wish in your own time. But of interest for us this morning are the business analysis libraries down at the bottom here. So we've got an as-is, a to-be-1, and a to-be-2 library. So the as-is is the way we do things today. And if I come into this library, you'll see it's a clone of the one we were just looking at. What's different? The process is the same. What's different, however, are the tools supplied with the business analysis library. And the first tool we have here is the process status report, and that's what I'd like to focus on to begin with, is to have a look at how this process status report is generated and the type of content it contains. So what I'm now going to do is flick back into the client environment. So this is the environment where maps are edited and where you actually add the data that you're dealing with. And I'm just going to connect up to the as-is library. So that's where my focus goes. And you can see corresponding to each of the maps we were just looking at, there's a corresponding Visio file. If I now right click, I can load that file in Visio, and we can start to have a look at, from the authoring perspective, as what that file contains. Okay, so as you'd expect, this file is a direct equivalent of the maps we've just been looking at online, with the trigger point, and we're cycling through. Because I'm in the analyst toolset, I've got the metrics I'm most interested in currently displayed on this map. That's something we can turn on and off at choice. And you'll see up at the top here we have the Triasta toolbar with various tools that we put together for you. So from this environment, I can now click down into, or if you like, look behind the data in the shape. And you see we've got here a data palette that it's out of the box, but again you've got complete control over this. You can change it to have exactly the data you need for your business analysis activities. Most clients typically have some kind of RACI model, some kind of process management, ISO, quality audit, that type of thing. Some of the data in there to support that. Where we're interested this morning is the business analysis domain. So we're looking at attributes that help me understand how long this process takes, how much it costs. So cost per hour, number of people involved, and the total working time, if you like, of that. Now, with this data here, I'm then able to compute costs. So wherever possible, we encourage you to use formulae to compute costs. And again, out of the box, the cost obviously is the multiple of the cost per hour times the number of hours required to work. That gives me the 140. The cycle time there of this particular activity. And you can also see we've got the value added status fields here, so I can flag any activity as value adding, non-value adding, or necessary non-value adding, and that will then give me the time here. Okay, so every object in the process library has this kind of data underpinning it, and we can therefore say for any given object how much it's going to cost. What we're particularly interested in, though, from an analyst perspective, is what the cost is of the whole end-to-end process if I were to walk through it from beginning to end, taking into account the fact that there are branch points and alternative pathways through the process. So you can see, for example, on this particular one, 10% of the time the process stops after one step because we reject the supplier. 90% of the time, however, it carries on where we go through the contract negotiation. So if I'm trying to understand the total end-to-end cost, I have to take 90% of the end-to-end cost along this pathway and 10% of the end-to-end cost along this pathway as some kind of aggregate or average cost for the end-to-end process. Very difficult to do that, especially if there are back loops, several branch ways, and that type of thing. So the best way to do it, or in fact the only way that it can be done really, is through a simulation technique where we walk through the process thousands of times, and every time we hit an object that has a cost, we add it to the average, and at the end divide the average by the number of times we've walked through that process. In order to do that, we need to first satisfy ourselves that the process is in some sense well structured and well formed. So there are a few tools in the product that enable me to do that. So let's just have a look at a few of them. We like to use diagrams wherever possible, so I'm going to start by having an overview of the process from beginning to end on a single page. So I'm going to generate an end-to-end diagram, and we'll see that loading in just a second. The end-to-end diagram, if you like, is like a plotter view or well, plotter view that you can print out on a plotter and hang up on the wall. So it's all of the processes combined in one diagram, if you like, and where there are links, the links are shown as well. So we'll just let that build. Okay. Yep, so that looks pretty good to me. I've got a you can see the green arrows are the links forward, and we do have a back loop that slightly confuses the layout on this, but I'm quite satisfied that that's a well-structured diagram. I've got no islands. Islands are the main thing. These will be processes that are just hanging there with no inputs or outputs. So I've got a fully connected diagram here. Each of these, when you zoom in, you can see the details. So if I were to print this, I could walk through it with my customers, with my team, and show them how all the processes connect together. So there's my end-to-end process diagram. I'll quickly do a hierarchy diagram also. The hierarchy diagram is a similar visualization, but gives me some kind of idea of top to bottom structure, if you like. So if I were using drill downs, for example, which in this particular model we're not, but this would enable me to see very clearly the tree-like structure of the process diagram. So there you go, nice and easy. Each of these objects is linked in to the corresponding process map if I were to click on them. Okay, so again, I've got a well-structured tree here, exactly as I'd expected, 4 top-level processes, each with broken down into detail underneath. A similar type of structure, by the way, which is commonly used, is in the Gantt chart view. So if I wish, I can export this whole thing out to, say, a project file. go to load Microsoft Project. Let's load Project 2010. So I can now directly import into project files the export from the process library. This is a fantastic tool. It enables us to initiate projects from the process definition rather than from some independent definition. And again, if I were to have drill downs, they would be subtasks. You can see it's carried through the duration estimates. And this is it's a model. It's really very powerful, and in the business analysis domain, can be used, to drive all kinds of integration activities with projects and various other things. Okay, so I'm satisfied that this is a well-formed. I won't bother opening that. I'm satisfied this is a well-formed set of processes. And so now I'd like to generate the process status report. So what I do is come back into my client side, process metrics, generate process status report. So this is the tool that fires off the simulation activity. And you'll see in the bottom left window there, it's now stepping through. Each run is a step through from beginning to end of the process until it gets to an end point. And for today, we're just going to do 1,000 runs. It's not uncommon to see hundreds of thousands, even millions of runs. There's no restriction. It can run overnight on large complex processes. Once that simulation activity is complete, we can then look at the summaries of the outputs, and that's what the process status report is. It's essentially a summary of the data that the simulation finds. So I come back into my business analysis library, click on the link. That 500 error is, if you just click refresh, that will open. Okay, so just to double check the time, 9th of November, 0944. So in other words, it's the report that was generated just a moment ago. And if I start to look at the content of this report, we can see it's broken down into various sections. The one that's of most interest this morning is this cost, time, effort bit, but also there's quite a lot of other information in here which is useful. So let's just focus on this table now. So this table is the process, the overview, if you like, of the current as-is process and what its major performance metrics are. So in terms of cost, we're estimating £4,500. In terms of effort, we think 150 hours. Quite a lot of wait time in this process, 277 hours. Therefore, the total calendar time or clock time or cycle time, i.e., lapse time from beginning to end, is 429.61, and in Six Sigma, that's often called the cycle time. We can see that the activities that were flagged as value adding are isolated out here. So of the total time, we can see 36.69 hours is value adding. Therefore, this 8.54% here, which is the proportion of value adding time in the process, and again in Six Sigma it's referred to as the process cycle efficiency. That's a key metric that's useful to understand process change. If I compare one process with another, and if I compare an as-is with a 2B, and the 2B has gone up or down in terms of process cycle efficiency, it's a good clue as to whether or not the process has fundamentally improved. So it may well be that steps are removed from a process in order to save cost, but if the value-adding steps are removed, we'd expect to see the process cycle efficiency drop, and that's never, well, typically not a good thing, although clearly it can be sometimes. Now this report is there for you to look at, so I'm not going to go into detail on everything in the report, but I will just focus in on this table for a moment. You can see that every object that was encountered in the simulation runs is now tabulated, and if you recall, we had a look at that branch point where it was 10% and 90%. So therefore, even though this object is in the end-to-end process, it only happens 90% of the time, and therefore the contribution to cost of this particular bit of the process would be every time it happens times 0.9. In other words, it's the instance cost, how much it costs whenever we perform that activity, times the probability it's encountered. And that's what we use to derive an end-to-end process cost. So this table is very useful. It's showing me where the biggest contributions to cost are coming from, and clearly that's where I'd focus my efforts if cost was the thing I really wanted to reduce. Various other sections of this report, which I'll leave for you to have a look at yourself. So I'm going to close that down. And with that report, we can also have a look in detail at some of the the data underpinning it. So I'm not just restricted to the Word document. I've also got a metrics model here, which, if I open that, so that was also uploaded at the same time we did the simulation. And again, it's on the internet there, so that you're able to see it for yourself. So it's just taking a second to download. So what we've got here is it's the same data as appears in the PDF that we were just looking at. If I were dealing with several end-to-end processes, they'll be tabulated here, and you can see for each of them I have the key parameters isolated out. But of interest more, I think, for a business analyst is the underlying data set here. So let's explore this a little bit. Every end-to-end process has more than one way through it. So we call those ways pathways. A pathway is a unique sequence of activities and deliverables, and every branch point therefore represents another pathway. When we have back loops, each loop represents another pathway. And in this particular example, there are 4 pathways that have been identified. And we can see in the first column, we've got the proportion of how often that pathway is executed. 81% is pathway 1, 2% is pathway 4. This is quite useful because what this is showing me is if I'm interested in trying to improve efficiency, reduce costs, or do something with this end-to-end process, then clearly pathway 1 is the one I need to focus on because that happens 80% of the time and therefore has a much bigger impact on the costs, etc., than for example, pathway 4 does, which only happens 2% of the time. All of the metrics included in this file are not, it's every single metric that you might want to capture appears in the spreadsheet, not just the ones in the PDF, obviously, because it's a summary. We only put the summary metrics in. But here we've got the complete data set underpinning the process. And if I just expand this window a little bit, we've also got the detail of what each pathway is. So the specific steps that are encountered on that pathway are highlighted out, together again with all of the data for each of the objects on that pathway. So you'll be able to see that pathway 1 clearly and pathway 2 are very, very different. Pathway 3 and pathway 4, if I just flick between the sheets, you can see they start to differ on row 41, I think it is. In other words, the 40th object. And the final sheet here is my difference matrix. So this is telling me clearly where you have pathways with tens of thousands of objects, you need to know quickly where they differ. And 40 there represents where pathway 3 and pathway 4 diverge. 28 represents where pathway 1 and pathway 2 diverge. Sorry, pathway 3 and pathway 1. And then finally in this model we have the complete database of every object with all of its attributes. So the spreadsheet models themselves, this is the raw data. You'll see every other piece of information in here is a lookup. So if I want to, I can come into the base data, change some of the values here without needing to rerun a simulation or go back into Visio and see the impact on the end-to-end costs if I were to make those changes. Okay, so we have a PDF and a spreadsheet model which together give pretty much all of the information that a business analyst could need to do their job. Where we're now going to finish off is a look at what's called the process comparison report. So this report here does not pertain to a single process, it pertains to the as-is compared with the to-be reports. So that was generated just a few minutes before the webinar started, so we had it available. And you can see here, we've got, well, let me just start with the table of contents. The as-is, this is the idea is an as-is to the to-be comparison. So for every end-to-end process that we're working with, in this case it's only one, we'd be able to compare it with its 2Bs based on these parameters. And we have a look at the table here. The as-is process currently costs £4,500. You can see that there's some significant cost reductions to be had through, in this case, through an automation, and that enables us to, it's certainly part of the evidence to consider when considering if we should move. As well as a cost reduction, there's a big reduction in cycle time, and you can see that the effort's reduced a lot. So essentially, this is a project to automate an aspect of the process. On the face of it, that looks like a pretty good step forward. Clearly, the next question is, well, how much does the automation cost, and is it worth it on that basis? As well as the basic parameters here, again, the Lean Six Sigma stuff that analysts like to work with, we can see that although the cycle time is reducing, the process cycle efficiency is remaining pretty stable. So the value add component, if you like, of the process is not going up or down either way. So that's pretty neutral in that respect. But everything we're looking at, sorry, not the value add proportion. So although we've taken time out and value added time out, because we've taken the non-value add steps out too, it's looking pretty consistent. And then finally, we can tabulate what the annual costings may be based on an assumption of how many times we do this per annum. So we've got a cost per process execution, which is then annualized, and we can see therefore the cost savings to be had are really quite substantial on this particular one. Now, we're not suggesting that this alone is reason to change. What we're saying is based on the simulation output and the best understanding we have, here's some supporting evidence to support a business case for change. That then needs to be taken into account with all of the other things that go into that decision. For example, is it a headcount reduction? If so, do we really want to do that? Are there other factors at play that make us fearful that the risk has gone up if we were to automate this, or whatever it may be? But at least we can see that there's some quantitative data in support of any decision to do process change. Okay, so that process comparison report, the various output formats that we looked at, the end-to-end diagram, the project Gantt chart, the metrics model, and the process status report collectively represent, many of the tools that we think business analysts need, and certainly in terms of Triasta, they're very, very simple to work with and simple to get these reports generated. So that's it for me for today. I'm going to stop there now. These tools are available on the internet. Anybody who wants to can come in and have a look after the webinar, and please always feel free to contact Triasta, info@triasta.co.uk if you have any further questions or would like to explore the ideas in this webinar any further.